Hello everyone, myself Bhuvanashri VS. I am currently pursuing my civil engineering in SVCA Bengaluru. Today I will be presenting my video assignment. My topic is capillary rise and capillary fall. Introduction. Capillarity is defined as the phenomena of rise or fall of a liquid surface in a small tube relative to the adjacent general level of a liquid. Capillarity. Capillary action is the movement of liquid in the upward direction with the solid surface. This is caused by the attraction between the molecules of liquid and solid. Molecular attractions arise due to the forces such as adhesive, cohesive, and surface tension. Capillary rise. Capillary rise is a phenomena in which liquid spontaneously rises or falls in a narrow space such as thin tube or in voids of porous material. Let's derive the equation for capillary rise in water. For this, consider a glass tube of small diameter d which is open at both the ends and it is inserted inside the liquid. As soon as the tube is inserted into the liquid, the level of water will rise above the general level of liquid. Let h be the height of the liquid, sigma be the surface tension of the liquid, theta be the contact angle between the tube and the liquid, rho be the density of liquid which is 1000 kg per meter cube, g be the gravitational force, and d be the diameter of pipe. For a capillary rise, both surface tension and pressure of fluid will be acting in upward direction. The weight of liquid of h height in the tube is equals to density into volume into gravitational force. We know that density is rho and volume is area into height. Area is pi d square by 4 into h. H is the height and g is the gravitational force. Next, weight of liquid of h height in the tube is equals to pi d square rho g h by 4. Call this as equation number 1. Next, we have to resolve the surface tension component like into horizontal component and vertical component. Upon resolving, we will get sigma sine 90 minus theta, which is sigma cos theta, and horizontal component we get as sigma cos 90 minus theta, which is sigma sin theta. Since we want vertical component of the surface tensile force, we consider sigma cos theta into pi d. Pi d is the circumference of the pipe. Next, equating equation 1 and equation 2, we get pi d square rho hg by 4 is equal to sigma cos theta into pi d. Here, pi get cancels, d one time and d one time get cancelled. We get d rho hg by 4 is equal to sigma cos theta. Since we are deriving the equation for capillary rise, we have to formulate the equation for h. For this, upon doing the calculation, we derive at h is equal to 4 sigma cos theta by rho gd. We know that the value of theta between the water and clean glass tube is equals to 0. We know the value of cos 0 which is equals to 1. Next, h is equal to 4 sigma into cos 0 by rho gd. We know that cos 0 value is equals to 1. Next, h is equal to 4 sigma by rho gd. This is the equation for capillary rise. Capillary fall. Capillary fall corresponds with the falling of the liquid. It is also known as depression of fluid, where this is the general level of mercury. As soon as the tube is immersed in the mercury, there will be decrease in the level of mercury. So this is the depression of fluid. Let's derive the equation for capillary fall in mercury. For this, the glass tube is dipped in mercury. This is the general level of mercury. As soon as the tube is dipped, there will be decrease in the level of mercury. This is also known as depression of the fluid. Then h be the height of the depression on the tube. For equilibrium, two forces will be acting on mercury inside the tube. One is surface tension sigma and the pressure of fluid. They both will be acting in opposite direction. The hydrostatic force acting in upward direction is equal to the intensity of pressure at the depth h, and it is given by density into volume into gravitational force. Then we derive at pi d square rho hg by 4. Call this as equation number 1. For capillary fall, the surface tension sigma and the pressure of fluid will be acting in opposite direction. If the surface tension acts in downward direction, then the pressure of fluid will be acting in upward direction. For capillary fall, always the surface tension acts in downward direction and the pressure of fluid will be acting in upward direction. Next, force of surface tension acting in downward direction is equal to sigma cos theta into pi d, where pi d is the circumference of pipe. Upon equating equation 1 and 2, we get pi d square rho hg by 4 is equal to sigma cos theta into pi d. Next, d rho hg by 4 is equal to sigma cos theta, where pi get cancelled and db get cancelled. Next, d rho hg by 4 is equal to 4 sigma cos theta. Since we are formulating the equation for capillary fall that or depression in the height, that is h, we have to formulate for h. H is equal to 4 sigma cos theta by rho g t. For mercury, theta value is not equal to 0, and for capillary fall the value of theta is not equal to 0. The value of theta for mercury is 128 degree. Therefore, H is equal to 4 sigma cos theta by rho g. This is the equation for capillary fall. Thank you.